Hello friends, we will now go for differential equation. It is just the application of derivative and integration we have learned so far. So firstly we will see what a differential equation is. Differential equation is an equation in the terms of dependent and independent variables along with the derivative of dependent variable. What is dependent and independent? See, if I am just writing y is equal to x plus 3, see here that y is depending on x. So y is a dependent variable. So differential equation is equation involving x and y. Suppose it is x plus 3 dy by dx, that is the derivative of the dependent variable, plus 5y equal to 0. This is very simple differential equation. In simple language, I can say that equation containing derivatives and variable is differential equation. Very easy to identify. Now we will see how to characterize differential equation. How to identify which type of differential equation is this. The differential equation is characterized by its order and degree. So order of differential equation is the highest derivative present in that equation. See, if I am writing x d square y by dx square plus y dy by dx plus 3 is equal to 0. Can you tell me the highest derivative present here? Yes, the highest derivative is this, second order derivative. So the order of the differential equation is 2 here. So we can easily identify the order of the differential equation is actually the highest derivative present in the differential equation. Sometimes what we see, some radicals are there, some roots are there. We have to get rid of that. After that, we have to go for finding the order, and I will say the degree. Okay, now degree of the differential equation is the power of the big boss, the highest derivative. Suppose this is a differential equation. Its power is 3, its power is 4, like that. Can you tell me what's the order? Order is very easy to identify. Order is 2. You have got. Now you have to see the power of the big boss, not the highest power. The power of this is 3. So the degree of the differential equation is 3. Very easily you can identify. Don't be carried away by this power 4. This is the power of one order derivative, first order derivative. But the order is second, so the order of the differential equation is 2, so power of that will be taken care of. Now we will see how differential equation is formed, how many derivatives are needed to form a differential equation out of a simple equation. See, one example I am taking. If y is equal to a cos 2x plus b sine 2x. Just general rule is there. How many variables, how many parameters, how many arbitrary constants are there which we have to get rid of. That decides how many times we have to differentiate. See here, two parameters a and b are there. So to get rid of a and b, we have to differentiate that twice, 2 times. If 3 parameters will be there, we need to differentiate it 3 times to get rid of the parameters. But if we need to solve the differential equation completely, we will need actually 3 equations. One is the original one and the 2 will be the derived ones, differentiated ones. Okay, so you just concentrate how to get rid of the parameters. I am just differentiating this once. So it is giving you dy by dx is equal to a into cos 2x is minus 2 sin 2x. Is it? Cos 2x is sin 2x minus sin 2x and 2x is 2 plus b, this is 2 cos 2x. So we haven't got rid of a and b. We will again differentiate this. So on second times differentiating, we are getting, this is minus 2a constant, outside I am taking, sin 2x is 2 cos 2x, yes, and here you see this is 2b cos 2x is giving you minus 2 sin 2x. So if you take minus 4 common, you are just left with cos 2x plus sin 2a cos 2x plus b sin 2x. And you just look at the original equation. This is exactly the y. So this is d square y by dx square is equal to minus 4y. So we got the differential equation out of the simple equation and we got rid of the parameters. This is how you can form the differential equation. You just learned in this video the degree, the order of the differential equation, how to find them and how to get rid of the arbitrary constant. You just differentiate, you will get things. Now we will see solving of differential equation. How to solve. Our differential equation is containing dy, dx, and we have to make dy as y, dx as x, and that is possible only with the help of integration. So to convert a differential equation into a normal equation is known as solving a differential equation. Differential equation solving is of two types, broad category, that are, I just name them, easily solvable. You just name it variable separable. That means where the variables can easily be separated. What does this mean? See here. If it is dy by dx is equal to x plus 5, like that, okay, we have to form an equation in the terms of x and y. How we will do? See here. We can just write, just follow the technique. You write dy one side, dx to other side. The first step, very important, take the things containing x to the dx side and the things containing y to the dy side. So we can just write x plus 5 here and nothing. Suppose y is there, so we can write y dy is equal to x plus 5 dx. The second step is we have to just go for integration to get rid of dx, to make dx as x, to make dy as y. So we just go for integration. It is coming out to be, see here, it is y square by 2, is it? And this is x square by 2 plus 5x plus c. This is the solution of the differential equation. Very easy. That is variable separable. But all the time you won't get the equations where the variables are easily separable. We have to follow the techniques we will be developing to solve them, to make them variable separable. The ultimate goal of differential equation solving is to make it variable separable only. Then we can easily integrate and we will get the solution. One more example I am taking. If dy by dx is equal to e to the power x plus y. Okay, the first step I told you, make dx to one side and dy to other side. So it will be dy here, dx here, and this can be written as e to the power x into e to the power y. So the term containing y is to be taken to dy side. So if I take e to the power y here, it will be e to the power minus y. Now variables are separable. Now just integrate. You will get integration of e to the power minus x is minus y is e to the power minus y by the basic coefficient of y is coming in denominator, so minus y. And here what is that? E to the power x plus c. This is the solution of the differential equation. Very, very easy, variable separable, but all the time you won't get that. Now we will see one type where variables are not separable, but that will be made separable. I just named this type of solving equation as unique relation type. What does this mean? There is a unique relation between x and y everywhere in the equation. Suppose I am writing dy by dx is equal to sine x plus y. You see, this is not variable separable. That means x and y cannot be separated. But you see, wherever x and y are existing, they are maintaining a unique relation. What relation is that? X plus y. We will give a different name to that relation. So if I just write z is equal to x plus y, that means that relation has been given a name z. Now you differentiate both sides to get the value of dy by dx. If you giving the name z to a particular relation, you have to transform everything in differential equation in the terms of z. So you need to get dy by dx, and that will be obtained by differentiating both sides. So on differentiating, we are getting dz by dx is equal to 1 plus dy by dx. So the value of dy by dx is here dz by dx minus 1 is equal to sine z. Yes, we got rid of y, we got a relation between x and z. Now this is variable separable. See, if I take 1 to this side, this is plus 1. So how to make it variable separable? Again the basic funda, dz to one side, dx to other side, z things to the z side and x things to the x side. Luckily no x thing is there. So if I take z thing here, it is 1 by 1 plus sine z. The next thing we have to do, just integrate. We have to integrate here and here. So on integrating, what we need to do, the basic, remember, you just remember that 1 plus sine z is there. We just rationalize this and the things will be easy. 1 minus sine z. What is coming here? 1 minus sine z. All the time I just recommend, I have told you in the course of integration, get rid of the denominator. Take care of the denominator. So it is coming out to be 1 minus sine z divided by a plus b into a minus b is a square minus b square. So 1 minus sine square z, that is cos square z. If you just divide it separately, it is coming out to be, and here on integration, it is x plus c. So what it is coming out to be, see here, it is 1 by cos square x, we know that is sec square x, minus sec square z it is, and here sine z by cos z is tan z, and extra cos z is giving you sec z. Very easily integrable now. It is in basic integration format. So it is coming out to be tan z minus sec z is equal to x plus c. Don't be carried away by c. You can put c here or there because that is constant only. So now you have to write whatever you have taken z. So this will be tan, and z we have taken x plus y minus sec x plus y is equal to x plus c. This is the solution of differential equation where there is a unique relation between x and y. One more example I am taking. Suppose dy by dx is equal to x plus y minus 1 by x plus y minus 3. See here, our unique relation is between x and y. What is that? X plus y. If you name that relation as z, as I did it here, this will be in the form dz by dx minus 1 is equal to z minus 1 by z minus 3. You just arrange in the terms of x and z and you will get the solution. So you are understanding now how to name the unique relation wherever it is existing. See here, it was existing 2 times here, but all the time same, x plus y. It can be like that, 2x plus y minus 1, and here also 2x. Again you can just name that relation as z. Hope you are understanding the basic variable separable and a unique relation type differential equation solving. Now we will see how to solve the homogeneous equation. Earlier we saw variable separable and a unique relation type solving differential equation. We will see homogeneous type. We will develop a technique that will be followed throughout in solving the differential equation which are homogeneous type. What is the meaning of homogeneous? Firstly, we will see that. Suppose dy by dx is equal to x square plus y square minus xy divided by y square minus 2xy, like this. See that degree of the variables is same everywhere. Degrees 2, degrees 2, degrees 1 and 1, 2, 2, 2. So everywhere degree is same. If that is happening, we will solve this by the technique we are developing here. In local language, I say, in the case of homogeneous type, first floor and ground floor both are existing with same degrees. So people just identify if any equation, differential equation is in the form something by something and the degrees is same, they just go for homogeneous. Easy recognition of homogeneous type. What technique we follow? We just put y is equal to vx. That is the substitution. It is, if it is dx by dy, we put x is equal to dy. Be careful. So if we put v is a variable here, on differentiating both sides, it is going to give dy by dx is equal to v as it is differentiation of x is 1 plus x as it is differentiation of v is dv by dx. That is very important. You just write this thing all the time wherever you have to replace dy by dx. So you just remember dy by dx is v plus x dv by dx. See some examples we are solving here. First case, dy by dx is equal to y square minus x square by 2xy. Degree is same, 2, 2, 2. So it is homogeneous type. What substitution we have to make? For y, we will write this. For dy by dx, we will write this. That is the only simple 2 steps. And you will get the equation in variable separable type very easily. So on doing this thing, what we are getting? V plus x dv by dx is equal to y square means v square x square minus x square by 2xy. X into y is vx. See what we are getting, x square everywhere in the numerator and denominator. We have to cancel it out. On taking x square common from both numerator and denominator, it is coming out to be v square minus 1 divided by 2v. So we got rid of x square here and it is coming out to be v square minus 1 by 2v minus v is equal to x dv by dx. On further solving, it is coming out to be v square minus 1 minus 2v square divided by 2v is equal to x dv by dx. We are just doing to separate v and dx so that they become variable separable and easily integrable. It is coming out to be minus v square here minus 1 by 2v is equal to x dv by dx. So now what we have to do, we have to take x thing to the dx side and v thing to the dy side. So it will be in the fashion dx by x is equal to dv 2v divided by, if we take minus common, 1 plus v square. Now it is easily integrable. How? By little bit of substitution. If we put 1 plus v square as t, 2v dv will be dt. So it will be in the fashion dt by minus t. So what is that? Here it is ln x and here it is minus ln 1 plus v square. Simple bit of substitution we did here to got it integrable. I just put 1 plus v square as t. Its derivative will be 2v dv. So this is dt. dt by t is ln t. So ln t we have taken 1 plus v square plus c. Now what we have to do for v, we have taken as y by x. You just replace v by y by x and your solution is in your hand. So it is ln x. If you try to bring this side, not a problem at all. Minus ln 1 plus y square by x square plus c. So this is the solution. Very easy. Now see in question number 2. This is dy by dx is equal to under root x square plus y square plus y by x. Now see here, is it homogeneous or not? Firstly see, it is not variable separable at least. Now we have to jump whether there is a relation between x and y, not a unique relation. Then we have to go for whether it is homogeneous or not. See here, it is degree 2 and power is 1 by 2. So degree is 1 degree, everywhere degree is same. So homogeneous. So we have to follow the technique of the homogeneous. What we do? We put y is equal to vx and we know that dy by dx is equal to v plus x dv by dx. So on putting that thing, it is coming out to be v plus x dv by dx is equal to under root x square plus v square x square plus vx by x. I can take x square common here. I will be left with 1 plus v square inside root. If I take x square outside the root, it will become just x. So a little bit of simplification, it is coming out to be under root 1 plus v square plus v, that's all, is equal to v plus x dv by dx. Luckily v is cancelling out here. So we can just write dx by x. I have taken dx to one side, dv to other side. The basic principle again I am following. See, I am writing here. So I will just write dv here and this here dv side, dx to that side and x to that side. So just integrate now. Now see the integration of this, it is in the form of 1 by under root 1 plus v square that we have seen in special integration 1, that is ln v plus under root 1 plus v square is equal to ln x plus c, constant thing. So now what we have to do for v, we will write y by x. So it is coming out to be ln y by x plus under root 1 plus y square by x square is equal to ln x plus c. So this is the solution. Very easily we can solve the homogeneous equation if we just remember the degree being same. We substitute this for dy by dx. We write this. We take dv to one side, dx to other side, v things to dv side and x thing to dx side. Easily integrate and we'll get the solution. Hope you are understanding homogeneous equation as well. We will see now linear equation. Linear equations in differential equations are those type of equations in which first derivative along with the dependent variable is present, but they are not in multiplication form. The standard form of linear equation is in the form dy by dx plus py equal to q. So it is in this format where p is any function of x and q is also a function of x. What does this mean? This p is anything containing x, q is anything containing x. It can be a constant also. It can be 3, 4, 5, 9, anything. It can be 2x, it can be x square, it can be sin x, like anything. Function of x or constant. For solving such type of equation, we need a technique and that technique is known as IF form. Integrating factor form. What is integrating factor? Integrating factor is actually that thing which when multiplied to both sides of the equation make it integrable. So we also term such type of equation as IF form. See here, how to find the IF? One example I am taking dy by dx plus 3y is equal to x. IF is actually, if I just take the example, it is x into y. So IF is taken as e to the power integration of p dx. This is the standard IF. All the time you need to find the IF, you just take e to the power integration of p dx. If the form is it not in that format, we will see that is dx by dy plus px is equal to q. In that case, IF will be e to the power integration p dy. Accordingly, it will change. No need of just worrying this thing. See here, what it is coming out to be e to the power integration of p is what here? X. So x dx is equal to coming out to be integration of x is x square by 2. So this is the IF. When IF is multiplied with the original equation, it is coming out to be e to the power x square by 2 into dy by dx plus x into y is equal to x into e to the power x square by 2. Now if you integrate both sides, the LHS thing will always come in the form y into IF. So you have to remember the step. It will be y into IF. What is IF here? IF is here e to the power x square by 2. So you just integrate this thing. How can you do? You just put x square by 2 as t and its derivative will be x dx. It is present here. You can easily integrate. The main thing is that by multiplying IF to both sides, the LHS thing is totally integrable easily and all the time it is coming as y into IF form. So again, I am just repeating. If the form is like this, first step is to find IF. Now multiply IF to both sides. LHS will always come as y into IF. You remember this step, the things will be easier. One more example I am taking. If it is x dy by dx plus y is equal to x square. So firstly we have to bring in that form. That means dy by dx should be independent of any coefficients of x or y. So On dividing by x both sides, it will be in the form dy by dx plus 1 by x y is equal to x. What is p here? See, if we just compare with the standard equation, it is 1 by x. So if is going to be e to the power integration of p, that is 1 by x dx. So what is that? E to the power x, e to the power ln x. So that is e and ln cancelling out, just x. So I have to multiply x, which is the if, to both sides of the equation to make it integrable. So on multiplying if, it is x into dy by dx plus x into 1 by x y is equal to x square. Now we just integrate. You just see how if is making it integrable. See here, this is actually the derivative of x into y. So differentiation of x into y is x as it is, that of y is dy by dx, plus y as it is, that of x is 1, and that is exactly in that form, and that integral is cancelling out the derivative sign. That is why I am telling you all the time, it is coming in the form of y into if we got here x, and here we just need to integrate q by 3 plus c. So we got the solution. So now once again I am telling you, if the form is in this form, you find if, multiply if, and the answer on integration is y into if, and you have to integrate the RHS thing. Hope you are understanding this also, and you will enjoy for the time being. Okay, bye bye.
If you like my videos, please subscribe my channel and share my videos.